Okay, we're starting with number 12 on our selected response. On a final exam, Alex answered 21 out of 25 questions correctly. He needs to score at least 80% to receive a B in the course. Written as a decimal, what portion of Alex's answers were correct? Well, he got 21 out of 25 correct. So we're supposed to write this as a decimal. Now I can T-bow this, but you know what else I can do? I can turn 25 into 100 so that we have hundredths. If I multiply this by 4, I multiply this by 4, and I get 84. And I know that 85 out of 100 is 84 hundredths, which is 84%. So Alex got 0.84. That's the decimal portion of his score. 21 out of 25 is 0.84. So written as a decimal, this would be 0.84. Now the next question is, how many questions need to be answered correctly to receive a score of 80%? Well, 80% means 80 out of 100. And there are 80 questions out of 100. And if there were 25 questions on the test, how many would he have to get right? So to get from 25 to 100, couldn't I multiply this by 4? And I would also have to multiply this by 4. Well, what number times 4 is 80? That number is 20, isn't it? So 80 out of 100 is the same as 20 out of 25. So if there's 25 questions possible and he got 20 correct, that would be 80%. 80% is 20 out of 25 questions correctly. So he'd have to get 20 correct to get 80%. So did he score at least 80%? Yes, he scored 84%. Give 2 reasons why. 8.4 equals 84%, which is more than enough, and he got 21 correct, and he needed only 20 correct to get 80%. So we know 2 different ways. We know that he passed with more than he got a B, because he got more than 80% and he got more than 20 questions right. Okay, let's look on the back. Okay, we're going to talk about this one in class, so we're not going to do that. A local middle school has 99 computers and 333 students. What is the number of students per computer? Students comes first. Students per, that line means per computer at the school. How many students per computer? Write your answer as a rational number, which would be a fraction in simplest form, and a decimal. Well, how many students are there? There's 333 students. And how many computers are there? There's 99 computers. So first we want to see that as a rational number in simplest form, which means we have to simplify or reduce. So you know how I like to reduce these. I like to factor them. See all these 3's? Look at that. And isn't 3 times 33 99? So I can do this. Now I know that 1 plus 1 plus 1 is 3, and 3 is divisible by 3, so that means this number is also divisible by 3. So if I take 111 and divide it by 3, I get 0, 2, no, that's a 3, Leffler, and that's a 9, and that leaves a 2, 21, and that's a 7. So 37 times 3 is 111. So 37 times 3 is 111, and 11 times 3 is 33. So now I can T-bow 37 over 11. Well, that's my answer as a rational number in simplest form, 33 over 11. So that means there's 33 students for every, sorry, it's 37 over 11. 37 students for every 11 computers. So how does that as a decimal? Well, let's T-bow 37, top in, bottom out, decimal. How many 11s are in 3? None. How many 11s are in 37? 3. 3 times 11 is 33. Don't forget those multiplication charts. Subtract, and you get 40. How many 11s are in 40? 3. 3 times 11, 33. 33 going up to 40 is 7. How many 11s are in 70? 6. 6 times 11 is 66. What's left? 40. How many 11s are in 40? 3. 3 times 11 is 33. Subtract, you get 70. I see repeating, so it's 3.36 repeat. So that means there are 3.36 students for one computer. All right, we're going to do 15 in class. 16. Sometimes the rational number 22 over 7 is used as an approximation of the irrational number pi, whose decimal form is 3.14159 ... This is irrational. This is pi. It doesn't terminate and it doesn't repeat. To how many decimal places does the decimal form of this agree with the decimal form of pi? So we're going to T-bow this. Decimal, decimal, 0, 0, 0, 0. How many 7s are in 2? None. How many 7s are in 22? 3. 3 times 7 is 21. Subtract, you get 1. Okay, how many 7s are in 10? 1. See how I have these lined up again. 1 times 7 is 7. Subtract, and you get 3. Bring down the next 0. How many 7s are in 30? That would be 4. 4 times 7 is 28. Subtract, and you get 2. Bring down a 0. How many 7s are in 20? That would be 2. 2 times 7 is 14. Subtract would be 6. Bring down a 0. 7s in 60 is 8. 56. 40. Okay, I think we have enough. So this is what we have here. This is pi 3.14159, and this is 3.1428. So the question is, to how many decimal places after the decimal does the decimal form of this agree with the decimal form of pi? Well, here's 1 decimal place. Those are the same. 2 decimal places. Those are the same. In the 3rd decimal place, they are different. So it's 2 decimal places. Okay, now we're going to do number 17. And number 17 says, no, we're skipping 17 and doing that one in class. 18. Write the decimal equivalents of 1/11, 2/11, and 3/11. Then use the results to predict the decimal equivalent of 9/11. Well, we're going to T-bow 1/11. Top in, bottom out,